Welcome friends. Today we will learn how to perform logistic regression in R. And this is your presenter. So now let us try to understand what is logistic regression, and then we will definitely go to see how logistic regression is run on R. Now logistic regression is a particular type of a regression technique in which the dependent variable is a binary variable. Binary variable means the dependent variable has only two outcomes. Generally outcomes like yes, no, outcomes like pass, fail, outside, outcomes like inside, outside. So something which has only two outcomes and which can be marked as 1 given the presence of that outcome or favorable event related to that outcome, favorable incident, like and 0 for the outcome not happening, or 0 for the outcome which is actually less likely. So that is the number of independent variables here can be 1 or it can be more than 1. Independent variables can be binary variables, it may be categorical variables also, and it may be continuous variables as well. So all possibilities are there for independent variable, but for the dependent variable there is only two outcomes like yes or no. Now given the values of the independent variable and given the value of the dependent variable, which is in the form of 0 and 1, we can predict the probability of occurrence of the event, that is probability of occurrence of y equal to 1. Y is the dependent variable, 1 means the occurrence of the events, and we can find the probability of y equal to 1 given the values of the dependent variable. So that is the purpose of binary logistic regression. Also we can find out which are the significant variables. Also we can use this for the purpose of prediction and so on. So the usual practices or usual things that we expect from regression, all things are available here. Also we can compare between the different groups. For example, we'll see it later on. Okay, so what are the groups? So we set some examples of binary logistic regression so that it becomes easier for you to understand what is binary logistic regression. For example, suppose if you fall in water, deep water, then some people can swim and come to the shore because they know swimming. Others will get themselves drowned. So suppose I want to take some people to the picnic, some students to the picnic, and we are going to a picnic near a lake, and where there is some bad reputation that every year some students drowns and collapses. So I wanted to ask my students how many of them can swim. So I am asking the students, do you know to swim? Some people are telling yes, some people are telling no. There is nothing in between, like yes I know, somewhat I know, not like that. Whether you know you can swim or you cannot swim. So answer students are giving in the form of 1 and 0. So that is my dependent variable. Now by the way, being a statistician, I at the end of my survey, I also wanted to find out that what are the reasons that some students they know swimming and some students they do not swim, cannot swim. So I took a information about their age, and then I also asked about their gender, and I asked also their place of residence, whether their place of residence in rural area, in urban area, because in rural area there are a lot of water bodies, so there is more possibility of a person to learn swimming because water bodies everywhere. In urban area hardly there is a water body just available. Maybe it's a lake or an artificial swimming pool where you have to get enrolled in order to learn swimming. So these are some things which are actually of interest. So these are independent variables. Another example is recovery from a disease after medication. Oh, so we are suffering from say headache. Many of us, we are given some medicine. We have consumed the medicine. Now after 6 hours or 8 hours, the doctor has come to survey whether the medicine has really worked and we are free from headache or not. Some people are telling yes, that is one, and some people are telling no. Now the independent variable are age group, which is ordinal. It is grouped, like it is not exact age, but here the age is in group. For example, in the previous example, age was in years, that is exact age, and here it is in age group, like say below 15 years, 15 to 30 years, 30 to 40 years, 40 to 50 years, like that. We have groups which may be equal, may not be equal, also equidistant. And then we have tobacco habit, whether these people whom medicine were given, they had a habit of consuming tobacco in some form, like smoking or in some other ways. So that's a nominal variable. It's just a name. It's yes, 1 and 0, no. And then also alcohol habit, whether they take to alcohol, that is 1 and 0. So in this case, you see none of the independent variables are ratio scale. That is, none of the independent variables are continuous type of data, but they are ordinal and either ordinal or nominal type of variables. Alcohol habit are also like nominal type of variables. So and so the all the independent variables are either ordinal or nominal. Another example, did you like the movie? Suppose we are given shown a movie and then we are asked whether we like the movie or not. Some people tell yes, some people are telling no. And then I want to find out that what determines the yes or no, what are the factors that influence their liking or disliking the movie. So I have age in years, which is measured in the ratio scale. Then we have educational qualification, which is ordinal. Then we have gender, which is nominal, like male and female. Then we have place in which movie was watched, that is whether it was watched in TV, whether it was watched in club, whether it was in mobile phone or in theater. So that those are also actually names of different places where we can have. So these are all examples of, except age in years, other things are all examples of either ordinal or nominal type of data. So these data are all coded, means when we will actually use that in the model, we will not write TV, mobile, but instead we will use their code. So that is the way in which the data set will be designed. Data set will be designed in that way. So if it is ordinal, then we can have 1, 2, 3, 4. But if it is nominal and more than 2 categories, if there are 2 categories only, then we can take 1 for male, 0 for female. But if there are more than 1, 2, 3, 4, that is more than 2 categories, then we will have 1 variable for TV, 1 variable for mobile phone, and 1 variable for club. Theater will not be there. Theater will be present in its absence. And then we can have TV. If you watch in TV, then 0. If you watch, if you watch in TV, then 1. Otherwise 0. If you watch in mobile phone, then 1. Otherwise 0. If you watch in club, then 1. Otherwise 0. And if you watch in theater, then all 3 will be 0. Theater as a variable will not be present in the model. So that is the concept of how we can arrange the independent variables for a binary logistic regression. Now, this is the mathematical form of a binary logistic regression. Here we are computing probability of y equal to 1. Y is our dependent variable, and what is the chance that y is yes. So that probability we are computing, and this is the regression equation. As we look at the equation, you will understand that denominator is always more than the numerator, and hence this value will be always be less than 1. You cannot exceed 1. So this will give me a probability. Also, there is no chance that this is negative, because e to the power anything will be always a positive quantity. So this is positive quantity, in the denominator also positive quantity. So no chance of getting a negative. And these will restrict the flow of the value probability of y. That is, this expression, left and right hand side of the expression will never go beyond 1 or less than 0. So now we have a perfect probability rate. If the values of the independent variable are known, that means if we know the value of x1, x2, once we fit the equation, we actually find out the value of b naught, beta naught, beta 1 and beta k. So we get these values once we fit the regression equation, and then we, knowing the value of x1, x2 dot 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 xk, we can find out the probability that y will happen. So this is the situation in which we are locked. Now, understanding the current data set. The data set comprises of information from 1067 married women who are in the age group of 14 to 49 years. The information of those 1067 women are collected from on the following variables. So this is a data set that we have on which we will perform or feed the logistic regression equation, and then we will find out that how we analyze and interpret the result. So there are 1067 women in my data set, and all of them age are from 14 to 49 years. That means so this is the total sample size, and this is the age, that these are all in the childbearing age group, and this information is collected from this number of women. Dependent variable is whether they use contraceptive or not. So if they use contraceptive, then it is yes, and otherwise it is no. So that is my dependent variable. It is quite clear and understood. Okay. Now the independent variables age group, it is classified and it is an ordinal variable. First code 1 is for less than 25 years of the age of the lady. Between 25 to 29, that is code 2. Between 30 to 39, this is code 3, and 40 to 49 is code 4. So this is coded. So we have these codes as 1, 2, 3, 4, and as you can see that the ages of the women are between 14 to 49 years. So we don't go beyond 49 years. Then we come to educational level, and if we look at the educational level of the respondent, then the educational level is we are using 1 for secondary level, and 0 for higher level. The secondary level means still say class 12. So if it is 12, then we have 1 code, and if it is more than that, then we have 0. So that is the code. So you should remember that here higher level of education is coded with a lower value 0. That you have to keep in mind. And do they have more desire to have more children? Because if they have desire to have more children, then they are expected to not to use contraceptive. So that is why this is 1 and this is no. If they don't want to have more children, then they should use contraceptive. So this is one variable we felt that make control the dependent variable. So this is our data set, this is our variables. So let us look at an abridged view of the data set. So this is the abridged view. Age group 1, more education level. 1 means they are on the higher level of education. More children, 1 means they want to have more number of children, and they are not using contraceptive. So the data set is quite large, as you have seen in the previous slide, that it consists of 1067 number of ladies. So it is quite large. We have only shown you only few values. Though this is the only a partial view of the data set. So when I want to run this data set, run this logistic regression in R, we actually type this data in Excel, and then we save this data in a file as we have given the name. We give other name also, but remember that the name should be simple, so that we require minimum typing when we call it in R. And obviously, as you know, that it should be saved in the CSV format. That is a mandatory requirement. And save it in documents, so that will make our typing easier. Otherwise, you have to give entire path name of the folder in which you have to save. But if you keep it in documents, then you don't have to give the full path name, and it is easier to call the data set in R. So we go to the R console, and in the R console what we do, first the data set we call it as a read CSV. So read CSV will header equal to true. As you know, either you can write true all capital or just T. So these will call the data set in R. So data set, this one is the data set bin underscore log.csv, and we have saved it in documents. From there, using the read command, we have called it here. Then we use the attach data command. Attach data command. This command is for assigning the data to the variables. So attach data. So attach data command, this is for assigning the data to the variables. So this command, as you know, have to be done in order to take the variables. So what are the variables? Age is variable, education is variable, more child underscore is there. So that are the independent variables, and contraceptive use either 1 or 0, that is the dependent variable. Now we name the model M. Here you may give some other name also. You may give M1, or you may give the name model. That is up to you. GLM, this is generalized linear model. So this is generalized linear model because this is a linear model, but it is a logistic, comes from the logistic concept. So that way it is called as a generalized linear model. And so you write GLM, then name of the independent variable, then contraceptive, then card, then age plus education plus more child. So that is the names of the independent variables associated with the plus sign, and family equal to binomial. That means you are telling that is a binary logistic regression or a binomial logistic regression. So when you write this command in R, the entire computation will be done, and all the information of the model will be saved under M. Next, we give the command summary M, and this will generate the output of the logistic regression. So this is the few commands that you have to do for running the binary logistic regression in R. So accordingly we get this, and let us try to understand what is this equation. Now this is the, as you know, this is the intercept, this is the partial regression coefficient with age, this is the partial regression coefficient with education, this is the partial regression coefficient with more child, And so I get my equation. This equation I put the value of beta naught, beta 1, beta 2, beta 3, and we get this is the equation. Now, out of these variables, leave along the intercept, look at age, p value, you see this p value is less than 0.05, and it is also flagged with a significant stars, and then more child, this is also less than 0.05, this is star, but education, it is close enough but not less than 0.05. That means education is not significant. That means the education level of the mother is not having a role in the, so far as this data set is concerned. About the use or not using the contraceptive. What are the variables important? Age is one important variable, and then more child is one important variable. So these are two things that we understand from this. Now, if we look at this equation, then well, this we can use for prediction, that is fine. But look at this. This should be x3 actually, not instead of xk, it should be x3. The third variable. So what is third variable? More child. And you see this value is negative. What does it indicate? It indicates that if person want to have more children, if the couple want to have more children, then the chance of using contraceptive decreases. This is quite obvious because person want to have more children, they will not use the contraceptive. So they are wanting to have more children, they don't use the contraceptive. Now, those people whose age increases, this is positive, you see it is significant, forget about the education level. So, this is significant and this is positive. That means as age increases, the chance of using contraceptive also increases. So, this is two important findings from the logistic regression. Now, let us see what other things I can use for the purpose of interpretation. One is the computation of odds ratio. Computation of odds ratio and its interpretation. So we use this command. You see there is a command here. There is a command here, this one. EXP within bracket COEF, that is coefficient of the model. That is model is M, that's why we are writing M here. Because in the previous slide, if you see that this model, we have saved it in M. And that's why we use this as M here. If I write the model name as M1, if I have saved their model name M1, then I will write M1 here. So this is e to the power value of the coefficient. So this is the intercept, this is the age after we take e to the power this age, education and more children. Now education you may ignore because it is insignificant. Intercept is of not of much use, so you may forget this. But what is this telling me? Let us look at this. How to find out this interpretation. So come here in this corner. So age equal to this value 1 point, this is called as odds ratio, minus 1 into 100. So we get 41.8. And you see this is positive. It indicates that as age group increases, the chance of using contraceptive increases by 41.8%. That means if you remember there were 4 age groups. They were coded as 1, 2, 3, 4. It means that as age group increases, the chance of using contraceptive also increases by, from one group to another, it increases by 41.8%. So as you go higher, the chance of increasing over the previous one increases by 41.8%. So this is suppose one group is a first group, for example. If the first group increases, chance of using contraceptive is 50%. Then the second group is 41.8% of 50%. So approximately say 40%. So 40% of 50% is 20% more. So that means 50 plus 20, that is they will go up to 70%. And the next group is 41% of 70%. So like this, it will go on increase the percentage of use. And more child, that means this value 0.0855 minus 1 into 100. It has come to 61.5%. That means that was a binary variable. Either you want to have more children or not. It means that the women who want to have more child, the chance of using contraceptive decreases by 61%. It is negative. So as you move from 0 to 1, the percent probability will decrease. Probability will decrease by how much? By 61%. That means if the people without say whose age is who don't want to have those who want to have children, if it is say 60%, then in the group which is wants to have more children, more child, that is 60%. And if those who are having don't want to have child, they will decrease of 61.5% of 60%. 61.5% of 60%. So that much will be the decrease. So it will come around something around 13%. So those who don't want to have, those who want to have more child, they will not use contraceptive, and those who want to have child, they will use less contraceptive. So this one who want to have more child, and those who don't want to have more child, their chance of using contraceptive will be more. So this is how we interpret this. This is called as the odds ratio. So odds ratio, so as you can read here, it indicates that women who want more child, the chance of using contraceptive decreases by 61.5%. So that is how this will go down. Now, overall interpretation of logistic regression. The logistic regression is run on the data. We actually summarize here, collected from 1067 Mary domain with use of contraceptive as the dependent variable. The independent variables of the model were education level, age, and a desire to have more children, all of which are categorical. So all of them are categorical in nature, as we have seen. The result showed that education level and desire to have more children are significant predictors. Oh, no, it is wrongly written here. And the result showed that age, it should be age and desire to have more children are significant predictors, where education level is not. Education level is not. While age is positively related, that means as age increases, chance of using contraceptive also increases. The desire to have more child shows a negative relationship. That means as you have the chance of, if you have desire to have more children, the use of contraceptive will decrease. So this is the concept that is been used, and this is how we interpret the results of logistic regression. Thank you for watching the video.